Whatever the focus of a business, it is essential to ensure they have a people and processes in place to collect the data and present it correctly. This means investment in systems and human resources. It does not necessarily mean that an organization need to go out and hire an entirely new team. Often it's mainly just a matter of upskilling the existing talent base. From the beginning, identify the right people and equip them with the necessary tools and training.
Our enduring challenge is ensuring that software development is able to keep pace with Moore's law. Software that generally works for gigabytes or terabytes of data wouldn't automatically scale up to petabytes or exabytes of data. We now generate 2.5 exabytes of data every day. This will increase to more than 400 exabytes of data daily by 2025. We must find ways to process this data in real time and to promptly generate meaningful insights at an acceptable cost. This, in my opinion, is the biggest challenge in data management at present.
Data mesh concept is designed to resolve the problems of centralized data management in an organization. It addresses issues such as siloed data ownership, lack of data governance, and data discovery and access inefficiency. By decentralizing data management and ownership, a data mesh setup allows teams to handle their own data, making sure it is easily discoverable and accessible to the correct set of users and systems. This results in improved and efficient data-driven decision-making and in turn supports the scalability of an organization's data architecture as it grows.
Whatever the focus of business, it is essential to ensure they have a people and processes in place to collect the data and present it correctly. This means investment in systems and human resources. It does not necessarily mean that an organization need to go out and hire an entirely new team. Often, it is mainly just a matter of upskilling the existing talent base. From the beginning, identify the right people and equip them with the necessary tools and training.
Data warehouses were intended to create a unified system of truth for an entire organization. However, manipulating the data itself and creating multiple data copies for different purposes at different levels in the data warehouse architecture has resulted in a complex system that is incredibly difficult, time-consuming, and expensive for organizations to create and maintain. While data warehouses are still beneficial, they suffer from some critical limitations in the current world of unlimited data. We are increasingly seeing organizations move to more flexible and decentralized data management, including data lakes and data mesh architecture.
SQL is a critical tool, and its declarative nature allows data engineers to express data transformations more clearly. Apart from SQL, the rise of Python has also made its way into data engineering, as it has been solidified as a highly robust programming language over the years. It is widely adopted due to its many built-in libraries for data processing and visualization. Some prominent examples are Pandas and Matplotlib. Another important tool is PySpark, which is an interface for Apache Spark that allows us to interact with data in a distributed environment. It's safe to say that Python and SQL were, are, and will remain an integral part of data engineering in one way or the other.
Most large organizations have different needs. Data warehouse, data lakes, and data mesh can coexist. But one undeniable trend is towards decentralization, local processing, and real-time processing. Looking at the volumes of data generated in real time, it might not be possible to perform centralized data processing at optimal cost and performance. In my summarized view, enterprise adoption to three primary themes: data democratization, data accessibility, governance, security, privacy, compliances, etc., Data monetization, key business objective and growth. And third, agility, accuracy of analytics. Real-time processing and performance as an example. In the case of machine learning models of software giants, there is a shift in approach. The previous model used to be where data would be extracted from devices and brought to a server for processing and machine learning. These days we noticed machine learning models are directly deployed into mobile devices and data is processed.
2023 will see a widespread adoption of data ops and ML ops processes, which combined with the already adopted agile methodologies will help companies reach next level data analytics and decision making. Analysts report that public cloud services investment is estimated to grow more than 20% in 2023. Companies worldwide are moving towards hybrid, multi-cloud and edge environments for cost, convenience and risk mitigation reasons. This new cloud hosting paradigm is enabling innovative distributed data processing architectures. Organizations moving from private infrastructure to public, hybrid and multi-cloud solutions will experience a significant increase in agility.
A data-driven culture is built around the trust in data. For this to happen, you must believe that the data produced represents the business environment you are trying to understand. Data needs to be in first-class citizen. An end-to-end responsibility for data quality needs to be ensured. Engineers must believe there is no difference between code quality and data quality. Data is a product. Therefore, data errors are always customer facing. A lack of investment in training is one of the challenges in creating a data-driven culture. So many organizations spend so much of time building high quality data sets rather than training their organizations on data literacy. Data teams should increasingly think of their roles as advocates for data. And part of that is helping people to become more comfortable with data and helping them develop solid mental models around data.
The current data trend that I'm most excited about is more of a mindset change than a paradigm shift. I see a degree of flexibility and openness in adopting modern data stacks earlier in their life cycle compared to the norm a few years ago. There is much more interest in and adoption of big data, federated data access, self-service portals, data virtualization, and data fabric regarding design patterns and technologies.
Data architecture is essential in keeping data secure and meeting compliance requirements. There are multiple ways in which this can be done, such as we can group data according to its sensitivity, for example, sensitive, confidential, and public. We can lower the collection, conservation, and sharing of personal data, which can reduce the chances of data breaches. And it also makes it easier to comply with regulations like GDPR and CCPA. Also, we can utilize some encryption methods to protect data both in transit and at rest. And finally, we can also introduce access systems like role-based or attribute-based access control for authorized user access.